Hello, and welcome to PreCalc Lesson 19. Today we're going to talk about nonlinear systems, factoring exponentials, and the sum and difference of cubes formula. So we have a lot to cover, so let's jump right on in. How would we solve this problem here? You guys have seen these in Algebra 2 already. We have a circle and we have a line, and we want to find solutions. Now, just to get us in the mind space, this is a circle. A line could either not cross it at all, which would be a really dumb math problem for them to give you. It could cross at one point, like that. And so you have one solution, or it could cross through the circle, and you would have two solutions. So our answer is either 0 solutions, 1 solution, or 2 solutions. So let's go ahead and solve this problem. The method by which you're going to solve these problems is pretty simple. First step, even though it is not our favorite method, we have to use substitution. If we have non-squared terms and squared terms. If you can eliminate an x squared and an x squared, go for it. But in this case, we can't. So what I'm going to do, and I can't emphasize this enough, please rewrite your problems in a way that it makes sense. If you just throw a bunch of equations and everything everywhere, it doesn't look good and it's really hard to follow. So I would encourage you to rewrite this whole thing, x squared plus y squared equals 9. And this one I'm going to rewrite as y equals x plus 1, moving the x to the other side. Then substitution says that I take this whole thing and I plug it in for y. So that's going to give me x squared plus x plus 1 squared equals 9. X squared plus 2x plus 1 equals 9. If I bring everything over to the left side, I have 2x squared plus 2x minus 8 equals 0. They all have 2 in common, so I'm going to divide by 2. I get x squared plus x minus 4 equals 0. Unfortunately, there's no number that nicely multiplies to make 4 and add, or negative 4 and adds to make negative 1. So I'm going to do the quadratic equation to solve for x. X equals negative b, remember b is this number, plus or minus the square root of b squared minus 4ac, 4a, c, all over 2a. So this looks like negative 1/2 plus or minus the square root of 17 over 2. Okay, 16 plus 1. So for each of these, remember that we could have 0, 1, or 2 solutions. For each solution here, of which I have 2, right, the positive one and the negative one, I now have to plug back in to my substitution part up here and solve for the solutions. So I'm going to start with the x equals negative 1/2 plus square root of 17 over 2. And I want to find out the specific y that goes with that x value. So y equals x plus 1, so I'm going to add 1 to that. One could also look like 2 over 2, right? Multiply it by 2 over 2. Now, I have negative 1/2 plus 2 over 2, which is 1/2 plus the square root of 17 over 2. Now, students are very tempted to just do this. That is wrong. Here's why that's wrong. Because this is actually implying that you have 4 solutions. The positive one with the positive one, the positive with the negative with the positive, the negative with the negative. And so we do not write out solutions like this. Instead, I have to write out each individual ordered pair. So this x goes with this y. Now I'm going to solve again and see what the solution is for that negative 1/2 minus square root of 17 over 2. By the same reasoning over there, we're adding 2 over 2. So this is a solution, and that is a solution. This x goes with this y, this x goes with this y. And that, my friends, is the first third of this lesson. Pretty tricky stuff. So let's jump back over here and we will continue. Seems like they pack these pre-calc lessons full of fun material for you guys to enjoy. All right, so next we are going to factor ugly things like this. That should be 2. And we've got 12 to the 12x to the 3n plus 3. There we go. So, what are we doing here? We are pulling out all the things that they have in common. It's really easy to see what 3 and 12 have in common. It's 3. But what about the rest of this problem? Remember that x to the 2n plus 2 is the same as x to the n times x to the n. That would give us x to the 2n times x to the 1 times x to the 1. That would give us the squared. Over here, x to the 3n is x to the n, x to the n, x to the n. X cubed is x times x times x. So what do these have in common? We have x to the n twice, and we have x to the 1 twice. So what am I left with? Well, I'm going to pull out the 3. I'm going to pull out x to the 2n plus 2. So what am I left with in the first equation? Well, I pulled out everything. And when you factor everything out, you're left with 1. Okay? Not with 0. You're left with 1 because 3, x to the 2n plus 2 times 1 is that. Plus, what am I left with here? If I pulled out 3, I'm left with 4 because 3 times 4 is 12. X to the 2n times what is x to the 3n? That would be x to the n. It's this one. Plus 1. So that is our factorization of this. I'm leaving the ones that I have left over, but I know that if I re-multiply these out, I get the thing that I started with. 3 times 4 is 12. 2n times n is 3n. 2 times 1, or x squared times x is x cubed. Let's try another one, because those are quite tricky. We have, this one's fun. X to the 2a minus y to the 2a over x to the a minus y to the a. Now, a lot of students just want to, oh, they give us plus. And these are b's. A lot of students just want to cancel. You can't cancel. You can only cancel when you have multiplication only, okay? So I have to find some way to factor the top and see if I can get an x to the a plus y to the b multiplied somewhere. So how do I do that? Well, I remember my difference of squares formula. In case you forgot it, if I have something squared minus something else squared, that equals a minus b times a plus b. If you multiply these out, you'll see that those middle terms cancel each other out. So how do I rewrite this in terms of that? Well, I want something squared. How about x to the a squared minus y to the b squared. That gives me a squared minus b squared. I'm left with the same thing on the bottom. Now I'm going to apply this formula. It says that if I have something squared minus something squared, then it's the first thing minus the second thing times the first thing plus the second thing. Now that I have multiplication on the top, I could potentially cancel if I saw the same term, which I do here. So the answer to this problem is simply x to the a minus y to the b. Because we factored. If you just canceled, you probably would not have gotten that solution. And it would have been poor math form. Now, the last part of our lesson today is the equation of the sum and difference of cubes. So when we have two squares, we can only do difference of squares or subtraction. I'll rewrite that equation here for your convenience. But for cubes, we can do addition or subtraction. So here are the formulas. You're really going to be tempted to put a 2 there. Please don't. Make sure you write these formulas down and have them in on your equation sheet. They come in at the most inconvenient and handy times. Notice that the negative one has the negative there, the positive one has the negative inside, if I am not mistaken. Yep. And so that, my friends, is problem set 19.